Alright, in this video we're going to learn about the quotient rule, right? This is another rule for differentiation, rules of differentiation. So we already learned the basic rules, the chain rule using to differentiate the composite function, and the product rule. And this one is the last one, is a quotient rule. So with these four rules, you can actually differentiate all the function very well. Alright. So quotient rule. So as a quotient rule is written as a quotient, right? It's a ux divided by vx. It's a function, it's a rational function here. So it can be any function, alright? So or I can just write it to be u over v, as you understood that u is actually ux and v is actually vx here. So the rule, the quotient rule, will be looking at this way. So first, the rule is writing back the v, you differentiate the u, du dx, then minus, write back the u, is like take turn, v first, differentiate du dx, subtract u, dv dx, then divided by v to the power of 2, right? Usually I will tell students in this way. So which will be easier for me to say will be u prime means du dx minus with u v prime over with v to the power of 2. So I will using this as my while I teaching, I will using all this. So this is the quotient rule. Alright, so how to using this quotient rule? So I'm going to show you in the next example. Alright, let's look at this example here. So this is a quotient, a rational function where the x cubed divided by 1 minus x, right? So the x cubed divided by 1 minus x. So then you have to identify your u, right? In this function, your u will be, this is your u over v, right? U over v. You learn how to differentiate this while you are in secondary school. So this is just for you to revision, right? U over v. So this is u and this is your v. So u will be x to the power of 3 and v will be 1 minus x, right? So you differentiate. So differentiate here means you du dx. Du dx, you have basic rule. Using the basic rule, you have 3x. 3 minus 1, you have 2, right? So your dv dx, differentiate 1, a constant, you're getting 0. Differentiate negative x, so you're getting negative 1, right? So means you know that your u prime will be 3x power of 2 and your v prime will be negative 1. So what you need to now is, what you need to do now is you apply the formula, right? So know that dy dx will be v u prime minus u v prime v power of 2. As you differentiate, you keep writing the formula until you're very familiar with the formula, then you can stop writing the formula. So this you must practice. So v is 1 minus x, right? 1 minus x, and u prime will be 3x to the power of 2. 3x to the power of 2 minus with u. Look at here, what is the u? U is x cubed, right? X cubed. V prime, negative 1. Very easy, right? And v to the power of 2. V to the power of 2 means that 1 minus x, everything to the power of 2. So now you have seen that I apply quotient rule. This is your u prime minus u v prime divided by v square. Okay, you can expand this one. So if you want, you can taking 3x square negative with 3x to the power of 3, right? 3x square, 3x cubed plus with x cubed. So you will have negative 3x cubed. So you have 3x square, negative 3 plus 1. You have negative 2x cubed divided by Oh, sorry. So divided by 1 minus x square, right? 1 minus x square. So right, 1 minus x square. So you can rewrite here, you're getting 3x square, negative 3 plus 1, you have negative 2x cubed, right? Negative 2x cubed over with 1 minus x to the power of 2. Very simple. You apply quotient rule, after you differentiate, this is the function that you get. Alright, let's look for another 2 examples. Alright, second example. So, a fraction in terms of a function divide by a function. So this is your u, this is your v. So you can write it out. So u is x power of 2 plus 1 to the power of 5, and v is 2 minus 5x according to this formula, right? You just have to follow the formula. Okay, so I start differentiating. So as you differentiate here, so your u prime, your du dx, right? Your du dx. This one is you using the chain rule to differentiate this composite function here. There is a power here, so you have bring down the power. So x to the power of 2 plus 1, and the 5, you go and minus 1 become 4. Your step 1, bring down the power, copy back this thing, and this one you minus 1, you're getting 4, and differentiate the function inside. So you have 2x plus 0, right? Differentiate 1, you're getting 0. So it means that your u prime is actually 5 times 2, 10x, x to the power of 2 plus 1 to the power of 4, right? And dv dx will be differentiate the constant, you're getting 0. Differentiate negative 5x, you get negative 5. So it means that your v prime is negative 5, right? Your v prime is negative 5. So this one is 5x squared plus 1, 5 minus 1, and differentiate the inside one. So everything, make sure it's correct, then you put into the formula. So you know that the formula will be v come first, then u prime minus u v prime divided by v to the power of 2. So make sure your formula is correct. Now you apply, substitute. So v, 2 minus 5x, right? 2 minus 5x, u prime, v, u prime. So 10x, x to the power of 2 plus 1 to the power of 4, right? This is your v, u prime. So minus with u, x squared plus 1 to the power of 5, v prime, right? V prime. So negative 5. Everything divide by v to the power of 2. V to the power of 2. This one, right? Your v. So become 2 minus 5x to the power of 2. This is very good already. You already know how to differentiate. So now, of course, it's continued by some algebra, right? Need to simplify. So how to simplify? So you just see how I do it. So usually I will factorize the common factor here. As you see that you have, okay, I can rewrite this whole thing first so that you can see better. So here you have 10x, you have x squared plus 1 to the power of 4. Okay, I straight away factorize because you see 10 and 5. You can take out the 5, right? You can take out the 5. You bring out the 5. Then you have x squared plus 1 to the power of 4. So I take out x squared plus 1 to the power of 4. I factorize the 5. Because 10 and 5, you can factorize 5. And x squared plus 1 power of 4 and x squared plus 1 to the power of 5, you can take out the least one, okay? The least. So you take out this thing so that you see inside, you see the function inside there. Still got any function that can be simplified or not. So then you have 10x, you have taken 5 out, so you have 2x, right? You have 2x. So this one, everything you already taken out from the bracket, from the bracket. So you still have 2 minus 5x, right? You have 2 minus 5x, This one become 2x, and minus with negative, positive 5. And this one 5, but you taken the 4. So 5 minus 4, you have x squared plus 1 to the power of 1, right? As you multiply, you get back power of 5, right? You get back power of 5. So this is what you supposed to do. So okay, sorry, because you already taken out the 5, right? So here you no longer have 5. No longer have 5 here. So be careful, because you taken 5, 5 factorized. So 5, 2, 10x, right? This one, power 4. This one, that's there. So positive here, negative, positive, right? But the 5 you already taken out, right? Taken out. So don't have 5 here. So x squared plus 1 to the power 1. Why is it power 1? Because 4 plus 1 is 5 here, right? So then you divided everything by 2 minus 5x to the power of 2. Okay, now further simplify. Alright? So maybe you will hate this job here. You better hate this one. Some students will hate this one, because you must be good in algebra. So now you have 5x to the power of 2 plus 1 to the power of 4. So then you expand this one. Expand. You have 4x 2 to 4x minus with 2 to 4x minus with 5 to 10x to the power of 2, right? 5 to 10x to the power of 2 plus with x power of 2 plus 1. Then divided by 2 minus 5x to the power of 2. Okay, further simplify. So you will have 5x squared plus 1 to the power of 4. Alright, what is inside here? Let's see. 4x, negative 10x squared plus x squared. So you have negative 9x to the power of 2, right? Negative 9 to the power of 2 plus 4x plus 1 plus 4x plus 1 divided by 2 minus 5x to the power of 2. This is the answer for this. This is a differential form of this function here. So as long as you understand how to apply the quotient rule, this is the most important one. Alright, let's go for another example, one more for you. Alright, this will be the last example that I want to show you for quotient rule. But later in another video, I will talking about differential exponent, ln, or the trigonometric function. We are still using quotient rule. At that time, you will still have a chance to understand quotient rule and product rule. So now, this is the primary primitive part of this part. This rule here is that I just want you to know how to use the formula, right? Formula. So as you know that your u here in this case will be 2x minus 1, right? U, v, and your v will be 2x minus 5. The square root means 1 over 2 here. So I du dx, differentiate, I have 2, right? Differentiate 2x, you have 2. Differentiate constant, you have 0. So then this one you have to apply the chain rule. So 1 over 2, bring down the power, that is the power, right? So 2x minus 5. And the 1 over 2, you deduct 1 minus 1, so you have negative 1 over 2. And don't forget that you need to differentiate the function inside there. 2, differentiate 2x, you have 2. This one you have 0. So you can cancel out the 2, right? So it means that your v prime is actually square root of 2x minus 5, right? Because 2x minus 5 to the power 1 over 2. So you have square root. So you have square root of 2x minus 5. So of course your u prime will be 2, right? Your u prime will be 2, and your v prime is square root of 2x minus 5. So now I'm going to apply the quotient rule to this function here. So if you have dy dx, so the formula will be vu prime minus u v prime over v to the power of 2 So dy dx, right? So your v will be, sorry, here I make a mistake here. Because there is a negative 102, right? Forgot that you have negative 102. Negative 102 is 1 over square root of 2. Because why? Negative 102. You can bring it become 1 over 2x minus 5 to the power 102, which is 1 over square root of 2x minus 5. So I make a mistake here. So okay, never mind. Let's continue. So your v will be square root of 2x minus 5, right? Yeah, your v is square root of 2x minus 5. U prime is 2, right? U prime is 2 minus with u 2x minus 1 v prime, so it's 1 over square root of 2x minus 5, right? So okay, everything divided by v to the power of 2. V to the power of 2 means that the square root, this one v power of 2, so you have 2x minus 5. So you have applied the quotient rule here. This is what is important now. So first you're able to apply the quotient rule. That is the most important one. Later is the algebra, right? So you carry out the algebra. So okay, let's see. I will do for you. All right. Let's continue. Let's continue by simplify this, right? Let's continue by simplify this. So okay. So you have equals to, so for this one you have 2 square root of x, right? 2 square root of 2x minus 5 is actually divided by 1, right? So I want to equate the denominator. Here you have 1 here, right? So here you have negative 2x minus 1 bracket over with square root of 2x minus 5, right? 2x minus 5 divided by 2x minus 5. Okay, so 1 minus with, so of course this one you should multiply with, you should multiply up and down by square root of 2x minus 5. This one also multiply with square root of 2x minus 5. So together all, you have a same denominator, which has square root of 2x minus 5, right? Now I talk about numerator, so you have square root of 2x minus 5. So on top you have 2x minus 5 square root of 2x minus 5, you have 2x minus 5, right? Square root of a, you have a. So minus with 2x minus 1. Don't forget to put the bracket. And you divide again by 2x minus 5. Okay, we further simplify, see whether what will we get. So 2, 2, you have 4x here, right? So I just write here, you have 4x, 2, 4x, minus with 10, right? 2, 4x, minus with 10. Negative 2x plus 1, right? So you finally you have 4x minus 2x, you have 2x, 4 minus 2, you have 2x, negative 10 plus 1, you have negative 9, right? Negative 9, so negative 9. So divided by this one and divided by this one. So together you just take this, multiply this. So means that the 2x minus 5 divided by square root of 2x minus 5. And these two, they have the same base here, right? 2x minus 5. So you can rewrite this one to be, you can rewrite 2x minus 5 with square root 1 over 2, which is 2x minus 5 to the power of 1 over 2, right? So then you here have 1, the base is the same, so you just add the index, 1 plus 1 over 2, 1 plus 1 over 2, so you have 3 over 2, right? So finally you have your answer to be 2x minus 9 divided by 2x minus 5 to the power of 3 over 2. This is much more simplified form compared to this, right? So that's all for quotient rule. Later I will using the same thing. I will using the basic rule, the quotient rule, the product rule, all combined together. Combination of all the rule in solving, differentiate all the different type of function that I'm going to discuss in the next subtopic.